Hello everyone, welcome back to the Ethical Hacking Course. In this section, we are going to dive into something really interesting, post-connection attack. These are the types of attack you can launch after you have connected to a target network. Now, it does not matter what kind of network it is, whether it's Wi-Fi or wired network, or even an Ethernet connection. Once you are in, you have got the keys to the kingdom. And trust me, there is a lot you can do from here. First up, you will be able to gather some really detailed information about every device connected to the same network as you. Think of it as a behind the scene look at what's happening on the network. Network scanning. See all connected device. You can find out things like IP addresses, devices name, and other key detail information that help you understand the network is better. But here is where it gets really interesting. You can also intercept data. That means you can see what other users on the network are sending and receiving over the internet. Get access to user info. That includes sensitive stuff like username, password, and other personal data. It's all out there for you to see. And it does not stop there. Once you are connected, you can even modify data as it's being transmitted. Imagine injecting malicious code into someone's browsing session or manipulating the data they are sending. Pretty powerful stuff, right? Inject malicious code. This gives you the power to perform some pretty advanced attack that can cause all sorts of trouble on the network. So, how do you actually pull this off? You have got two options. You can run this attack on a virtual net adapter, especially if you are working on a Windows machine. Just make sure your virtual Windows and Kali machine are connected to the same net network. Option 1, virtual net network. Option 2, you can run this attack against real computers on your actual Wi-Fi network. In this case, you will need a wireless interface on your Kali machine that's connected to the target Wi-Fi. Option 2, real Wi-Fi network. Throughout this session, I will be showing how to run these attacks in both setup. You will see me target my Wi-Fi network in some cases and use the virtual net in others. So you can get comfortable doing this in different environments. By the end of this session, you will know exactly how to execute these attacks, whether it's on your home network or a virtual setup. So remember, it does not matter how you can get access to the network once you are connected and you are in a control. Stick around because we are about to get into the fun part, running the attacks. I will be showing you how to download Windows 10 as a virtual machine for VMware directly from the official Microsoft website. If you are looking to test or use Windows 10 in a virtual environment, this is the easiest way to do it. So let's jump right into it. First, let's head over to your browser and open the official Microsoft website. And I will guide you step by step. Step 1. Search download Windows 10 disk image ISO file in your search engine and open the link. Now, once you land on the correct page, you will see a section titled Create Windows 10 Installation Media and press Download Now button. After downloading, click to run it. It takes us several times. After getting this page, scroll down and accept and wait for next page and select second option create installation media USB flash drive DVD or ISO file for another PC and press next and you can see a language edition and architecture. You can also change this from here according to your system requirement and press next and download ISO file for your virtual machine. I have already installed ISO file. So after successfully download ISO file, create a new virtual machine. Next, and browse your path here of your ISO file and open it and configure it. I have already configured my Windows 10. Net Discover. Imagine you are connected to a network and your target is one of the devices on that network. What is your first step? Figure out who is on the network with you. You need to gather details like IP addresses, MAC addresses, and other device specific info. Once you have that, you can use it to plan your next move, whether that's running attacks or digging for more intel. Now, there are plenty of tools to help with this. like Net Discover and Nmap. For today's video, we are going to start with Net Discover, which is perfect for quickly mapping out a network and seeing all the connected devices. In the next video, I will show you how to use Nmap for more detailed information. Alright, I have got my Kali Linux terminal open. First, I will run the command ifconfig to check my network interface. As you can see, I have an ETH0 interface with an IP address. Here is my IP address. This is because I am using a net network in a virtual machine. But the process works the same whether you are on a virtual or a real network. This is ETH0 interface represents my connection to the network. Even though it's virtual, the Kali machine thinks it's connected to a real Ethernet network. I have also got a virtual window machine on the same net network, simulating my target. Now let's run NetDiscover to find out what devices are connected to the same network. The command is simple: NetDiscover and R. The R specifies the range of IPs I went to search. My IP is 192.168.73.131. So I can only scan IPs in the same subnet, which is range from 192.168.73.1 to 192.168.73.254. Now enter your network first IP address 192.168.73.1 according to your IP address. Instead of man Instead of manually typing the entire range, I will just use 24 at the end of the IP address and NetDiscover will handle the rest. Scanning from 192.168.73.1 to 192.168.73.254. And there you go. NetDiscover shows me all the connected devices, their IP addresses, MAC addresses, and it even tries to guess the vendor based on the MAC addresses. You can press Q to exit the program. Simple, right? This works just as well for real networks, including Wi-Fi if you have got a right setup. Speaking of Wi-Fi, let's move to the wireless network. You will need an external wireless adapter if you are running Kali in a virtual machine, as the built-in Wi-Fi card won't be accessible. Now that I have connected to the adapter and configure it, I will run if configure again, and there it is, LAN 0. This is my Kali machine is now connected to a Wi-Fi network. This one, and we can scan for devices. Let's run NetDiscover again, but this time with my new IP 192.168.1.38, and I will set the range to 192.168.1.1 and 24 to cover the entire subnet. NetDiscover R. Enter your network first range IP 192.168.1.1 and 24 and hit enter. Whether you can see the devices list not shows perfectly because we don't turn off the net adapter. So first we need to turn off or disconnect the net adapter. Then run again. As you can see, it's discovering all the connected devices on the Wi-Fi network. Same command, different network, same reliable result. How easy it is to use NetDiscover to gather information about devices on the network. Whether you are working in a virtual environment or a real network, the process remains the same. But you need to turn off or disconnect the net adapter from here, from VM section, and remove old device and turn off network adapter and turn off net adapter. So in the next video, we will step it up a notch with Nmap and learn how to get more detailed information about each device. Nmap is an incredible, powerful tool for network scanning. While it's a bit slower than a net discover, the amounts of information it gives you about a target is on a whole different level. Nmap does not just show you who is connected, it tells you what ports are open, what services are running on those ports, the computer's name, and even the operating system. You will be able to discover everything from connected clients to bypassing certain security measures, including firewalls. Now, Nmap is a huge tool. There are books and entire courses just on Nmap. But don't worry, in today's video, we will focus on the basics. I will show you how to use it to discover connected clients and gather useful information about them. Instead of using the command line version of Nmap, we are going to use Genmap, the graphical user interface of Nmap. To launch Genmap, just type Genmap in the terminal or find it in your application menu. As you can see, Genmap has a simple interface. As you can see, Genmap has a simple interface. The first thing you will notice is the target input box. This is where you enter your target. It could be an IP address for a computer, a server, or even a website server's IP. Now, just like in the previous video with NetDiscover, we can also scan a range of IPs. GenMap will scan the entire range, discover all the live IPs on the network, and display details about them. I am connected to my wireless network right now, so I will set the range for this network, which is 192.168.1.1 and 24. At the bottom, you can see actual nmap command that will run when I hit scan and select the ping scan and hit the scan button. If you know custom nmap command, you can paste it here too. Nmap also has some ready to use profiles if you don't know much about nmap commands. In today's video, we will use a few of these profiles and see how they differ in speed and the information they collect. Let's start with the ping scan. This is the quickest scan. It ping all possible IPs in the range and any device that responds is recorded, showing that it's connected. Keep in mind, too, not all devices respond to ping requests, so the list might not include every connected device. Once the scan is done, we can see a list of devices along with their MAC address and vendors. For example, I can see one device with 198.168.1.1 is a device. This is my router. Another device is 192.168.1.40 is a Dell laptop. And as you can see, every connected device to the network. Now let's try the quick scan. It takes a bit more time than the ping scan, but it gives a more detailed information like open ports on each device. For example, my router port 80 is open. This port is used to accessing router setting through a web interface. We also see that the device has port 22 open, which is for SSH, which, which is for SSH, a service used for remote access. As we go through the devices, we can see which port are open and what service are running on them. This is crucial because these open ports could be potential point of entry, especially when we move to the next session on gaining access. In the next video, we will dive deeper into information gathering and see how it's helped us during hacking. For example, we will use the data we collected today to hack into an device connected to the same network. We took a brief introduction of GenMap and how it can help us to gather useful information about devices on the network. Today, we are going to build on that by exploring a more advanced scan, the Quick Scan Plus. This scan takes the basic quick scan to the next level. While it might take a bit more time, it gives us a lot more valuable information that can really help us in a later step, especially when we get into gaining access to the device. What does the quick scan plus do differently? Well, for starter, it not only detects open ports but also tells us the operating system running on the discovered devices, the type of device, whether it's a phone, laptop, router, or something else, version running on those open ports. For example, in the previous scan, we might have found that port 80 was open, but we didn't know what software was running on it or its version. Now with the Quick Scan Plus, we can see that kind of detailed information. Why is this information important? This level of detail is super helpful, especially later on when we start exploiting vulnerabilities. Knowing the exact version of a program allows us to search for a known weakness, making it easier to gain access to vulnerable systems. The device 192.168.1.40. Let's take a look at one of the device discovered in the scan. Let's take a look at one of the device discovered in the scan. This is computer device, and in our last scan, we know that port 22 was open, but we didn't know what version of SSH was running. Now we can see it's running Open SSH 9.6 PL Debian 3 Protocol 2.0. With this information, we can quickly look up known vulnerabilities for this version, which could be our way in when we move to the gaining access section. You also learn more about the device itself. It's a PC running on Windows. This detailed information can be critical when trying to decide what kind of attack we might use later. Now, thanks to the Quick Scan Plus, we can see the port 80 was running on Apache HTTPD. We can see that port 80 is running Apache HTTPD version 0.93.50 on Linux. This gives us specific detail that we can use to look up known exploits. Another cool feature is the ability to browse devices based on services. For example, we can look at all devices running HTTP service or SSH service by clicking on the respective tabs. It's a greater way to filter device if we are targeting a specific service. We have a computer on the network, the same device from earlier, running OpenSSH on port 22. Now device don't normally have SSH installed unless they have configured. Since this computer has SSH service running, we know it's configured. By default, the SSH password on user is Kali, unless the user has changed it. Unless the user has changed it, which most don't. So let's try to connect to this computer using the default password, and I will open the terminal. And I will open the terminal, type SSH Kali @ 192.168.1.40 and hit enter. When it asks for password, and I will type Kali. Now I am in as the root user. I have full control over this computer just by using this information we gathered. No complex hacking was needed here. It's just the power of information gathering. So you can see the Quick Scan Plus can give us a ton of useful information that we can use later when trying to gaining access to the device. In upcoming videos, we will dive deeper into this topic and show you how to use this information to exploit vulnerabilities and gain full control over the device. Make sure to try out the other scan profiles on GenMap and keep practicing. And if you want to go even deeper, I recommend checking out the Nmap book. It's fantastic resource. In today's video, we will begin exploring one of the most common types of cyber attacks, man-in-the-middle attacks, often called MITM. These attacks allow hackers to intercept communication between two devices, putting them in a powerful position where they can steal sensitive information or alter it. Let's dive into how these attacks work and why they are so dangerous. Normally, communication between two devices, like your phone and a website, happens directly. The information is sent from one device to other device without interruption. In a man-in-the-middle attack, a hacker sneaks into the middle of this connection. Now, every bit of information that passes between the devices is interrupted by the hacker. They can read, steal, and even change the data without the two devices ever knowing. One of the ways hackers can carry out a man-in-the-middle attack is through something called ARP spoofing. In ARP spoofing, the hacker tricks both devices into sending all their data through the hacker's computer instead of directly to each other. So, instead of data flowing directly between the devices, the information is intercepted by the hacker first. This means any passwords, private messages, or sensitive data shared between the devices will be passed to the hacker system. To understand how ARP spoofing works, we first need to understand what is ARP is. ARP stands for Address Resolution Protocol. ARP is a simple protocol used to connect IP addresses to MAC addresses in a local network. The IP address is like your home address. It tells other devices where your device is on the network. The MAC address, on the other hand, is like your device's personal identification number, which is used to send and receive data. Here is an example. In this network, we have four devices A, B, C, and D, and a router. Each device has both an IP address and MAC address. Let's say device A needs to communicate with device C. Device A knows the IP address of device C, but it needs the MAC address in order to send data. Here is how device A gets the MAC address. It sends out an ARP request, which is broadcast message to the entire network. The message says who has this IP address. All the devices on the network receive the request, but only device C responds, saying, I have that IP address and here is my MAC address. Now device A knows device C's MAC address and they can communicate directly. This process is happening all the time in the network to help device communicate smoothly. So, how does a hacker exploit this? ARP is a simple protocol with a major flaw. It does not verify if the response it receives is from the correct device. A hacker can take advantage of this by sending fake ARP response to trick both the router and the target device. The hacker sends an ARP response to the router pretending to be the victim's device and another ARP response to the victim pretending to be the router. This trick both the router and the victim into believing that the hacker is the device they are trying to communicate with. As a result, all the data from the victim is routed through the hacker's computer before it reaches the router, and the responses from the router are also sent to the hacker system before they reach the victim. Now that the hacker is in the middle of the communication, they can see all the data flowing between the devices. This could include sensitive information like usernames, password, and financial data. Even worse, the hackers can modify the data being sent. For example, they can change the content of a message, redirect you to a fake website, or drop the connection entirely, causing a denial of service attack, which is known as DOS attack. So, why is the ARP so vulnerable? There are two main reasons. First, device accept ARP responses even if they didn't send a request. This means a hacker can send a fake ARP message to a device that has not asked for them. Second, neither the router nor the target device verifies the authenticity of the ARP response. This makes it easy for hackers to impersonate other devices on the network. Let's look at the practical example. Imagine you are connected to a Wi-Fi network in a coffee shop. If a hacker is also connected to the same network, they can launch an ARP spoofing attack. The hacker sends ARP response to your device pretending to be the router and send a fake ARP response to the router pretending to be your device. Now every bit of data you send, whether it's browsing website, sending emails or logging into your bank account, passes to the hackers first. In summary, ARP spoofing is a powerful technique that hackers use to intercept and control communication between devices. By exploiting this weakness in ARP, they can steal sensitive information or disrupt the communication entirely. The best way to protect yourself from ARP spoofing and man-in-the-middle attack is to use encrypted connections such as HTTPS and avoid using untrusted networks. Now that we have a solid understanding of how ARP spoofing works, let's move forward and see how we can execute this attack to manipulate the flow of data, rewriting it to our own device. By doing this, we will be able to intercept everything sent to and from the target computer, including sensitive information like username, password, and more. There are several tools available to carry out an ARP spoofing attack. However, in today's session, I will be walking you through a simple yet reliable tool called ARP spoof. In upcoming lectures, we will switch to a more feature-rich tool called BetterCap. The reason I am introducing ARP spoof here is that it's extremely easy to use, but also very dependable. It's available across multiple operating systems including iOS and Android. So once you understand how to use it, you can deploy it on virtually in any system. With ARP spoof, we can redirect the flow of data to pass to our computer. After redirecting the data, you can then use other tools like Wireshark or Packet Sniffer to analyze the data, which we'll discuss further in this course. Let's start using ARP spoof. First, open your terminal and type ARP A to see gateway IP and MAC address on ETH0. Then type ARP spoof I ETH0. The I specifies the network interface connected to the target network. In my case, it's ETH0. In my case, it's ETH0. If you are unsure of your interface, run the if config command and you will see the one connected ETH0. For this demo, I will be using this attack on my virtual network. You can also run this on Wi-Fi networks, which I will cover later. For now, I will recommend testing it on virtual network as I am doing here. Next, let's specify the target IP address using the T. My target IP is 192.168.73.134. Now I'll copy that and paste here. You will also need to provide the gateway IP address, which is 192.168.73.2. So I'll write here 192.168.73.2. This will trick the target into believing that I am the router. Now I clear the screen and also run the same command. ARP spoof I ETH0. Now you need to enter gateway IP address 192.168.73. Now enter your target victim IP address and enter different key. Now enter your target IP address, which is 192.168.73.134. We will run the ARP spoof command twice. First, to fool the victim into thinking we are the router, and second, to trick the router into believing we are the victim. Now I will run the command here and here. Remember, this attack works on both wired and wireless networks. Here, I am using a virtual wired network, but the same approach applies to Wi-Fi networks. If you want to target a wireless network, you need to connect a wireless adapter to your Kali machine and follow the same process. After executing the commands, go to the target machine and run ARPA. ARPA. You will notice the MAC address of the router has changed to the match the MAC address of my Kali machine. You can also verify with old MAC address. Now, every request from the target will send to the my machine first. Now I am going to Kali machine. Since my machine is not a router, it won't forward the packets unless we enable port forwarding. To do this, use the following command: echo 1 greater than drop slash date IPv4 IP underscore forward. With port forwarding enabled, the target machine will still have internet access, but all the request and response will pass to our computer first. As shown in the diagram, the target's data flow to our machine before reaching the router. This allows us to position ourselves as the man in the middle. Once we are in the middle, we can inject code into the target's browser, still sensitive data like username and password, monitor all communication, replace legitimate file with malicious one, and much more. That's a quick demo of how to use ARP spoof for ARP spoofing attacks and how we can use a tool called ARP spoof to intercept connection within our network. ARP spoof is a simple, reliable tool and it's available across various operating systems. But now, in this and the upcoming lesson, we are moving on the more advanced tool called BetterCap, like ARP spoof. BetterCap allows us to perform ARP spoofing attacks, but it offers much more. With BetterCap, we can capture and analyze network data, see usernames and passwords, bypass HTTPS, potentially bypass HSTS, perform DNS spoofing, inject code into web pages, and so much more. I will show you how to run BetterCap and give a quick overview how to use it. We will dive deeper into the tool in upcoming lessons. To run BetterCap, All you need to do is type its name in the terminal, BetterCap, and if you want more information about its command and uses, you can type BetterCap help. We will be using this tool a lot throughout this course, and you will learn more as we go along. Starting BetterCap, let's clear the screen and run the command. I will type BetterCap iFace ETH0. Here, I am specifying the network interface with the iFace option. In my case, the network interface is ETH0. You can find your interface by typing ifconfig on your terminal. Ifconfig, you can see ETH0. Now I close the screen and hit the enter. You will be inside BetterCap and you will see a new prompt where you can start using its command. To get a list of all available commands, simply type help. Exploring BetterCap module. BetterCap operates using modules which allow you to perform different network attacks and data analysis. Let's take a look at two important modules today, NetProbe and NetRecon. I am going to type help NetProbe. This command gives a description of the net.probe module, which continuously sends UDP packets to discover devices connected to the same network. You can turn it on with the command net.probe on. Similarly, to turn it off, you have to use net.probe off. Now, entering the help command, and you can see the net.probe is running now. Now, discovering connected clients once you turn it on net.probe. It will automatically start discovering all connected devices on the network. For example, it might show the IP address of a Windows machine that's connected to the same network. When net.probe starts, it also triggers net.recon automatically. The net.recon module monitors the ARP cache and adds discovered IPs to a list, which we can target later. To see all the connected clients, you can use the command net.show. Net.show. This will give you a list of all clients connected to your network, along with their IP addresses and MAC addresses. It will even try to identify the hardware manufacturer of each device. That's it for today's overview. We have covered how to get help for BetterCap module, how to run them, and how to analyze the results. In the next lecture, I will show you how to use BetterCap to launch an ARP spoofing attack to intercept data like usernames and passwords flowing through the network. So I am going to show you how to perform ARP spoofing attack using a powerful tool called BetterCap. With this, we can place our computer right in the middle of the connection between a target device and the router, intercepting the data being exchanged. Not only that, but I will also show you how to read this intercepted data, things like URLs, websites, the target widgets, and even sensitive information like username and passwords. Sound interesting, right? Let's dive into it. Alright, the first thing we need to do is become the man in the middle. We can do this using BetterCap's ARP spoofing module. If I scroll up in the help menu, you can see there are a module called ARP spoof. To understand how this works and what options can modify, let's type help ARP spoof. Help ARP spoof. As you can see, there are a few commands to remember. For instance, you can turn on ARP spoofing on by typing ARP spoof on. Similarly, you can cut off the target's internet connection by typing ARP.ban on. But we won't be doing that here. To be disable this feature, you can simply use arpspoof.off or arp.ban off. In the last video, I briefly mentioned that we can adjust parameter for these modules, but today I am going to BetterCap makes this simple by providing the option name, description, and default value. Let's take the option ARP spoof full duplex as an example. Let's take the option ARP spoof full duplex as an example. This option, when set to true, will spoof both the router and the target device. By default, it's set to false, which means we only spoof the target machine. I will change it to true because we want to control both sides of the connection. So both the router and the target will think our machine is the other one. To do this, we simply type step ARP spoof full duplex true. Once you hit enter, the change is made and no errors mean it's executed successfully. Now we need to tell BetaCap which device is to target. There are an option called ARP spoof targets where we can specify the target IP. I am going to use the IP of my target device, which is my Windows Virtual Machine IP. Now check the Windows Virtual Machine's IP. You can use ARP if not checking IP address of Windows machine. Again, I will use the set command like before. Set ARP spoof, set ARP spoof targets 192.168.73.134. Here is my Windows Virtual Machine's IP address and hit enter. No errors, looks good. Alright, we are ready to start the attack according to the health menu. All we need to do now is turn on the ARP spoof module with the command ARP spoof on. Let's run that. The error message shows because my ARP spoof is already running. So I don't need to turn on ARP spoof because I have already running. So if we check by typing help again, you can see here ARP spoof is now active. Let's verify that everything working correctly. I will go over my window machine and run the command ARP A. As you can see, the router's MAC address has been replaced with the MAC address of my Kali machine. This means that any data the window machine wants to send to the router is now sent to our machine. Similarly, because we enable full duplex, any responses from the router internet for the Windows machine are also sent to our Kali machine. So we have successfully placed our computer in the middle of the connection between the target device and the router. This means that every bit of data, whether it's usernames, passwords, or web activity, will pass to our machine, allowing us to read, modify, or drop it. Now that we have placed ourselves in the middle, all of the internet traffic, whether it's URLs, images, videos, or even passwords, is passing through our computer. Today we are going to learn how to capture and analyze this traffic. So our computer is already in the middle of the connection and data is flowing through us. To capture this data, we will use the NetSnap module in the BetterCap. This module automatically captures, analyze, and display interesting data. To start, you can type help NetSnap, help NetSnap to see the available options. But for now, we will keep things simple and run it with default setting by typing snap snap on. This command will start capturing all the traffic flowing through our computer. Now that we have started the capture process, let's move to our target machine. For this demo, we will use a Windows computer and I will open the browser and generate some traffic to see if better capture it. For this example, we will visit a website called worldweb.com, which is not using HTTPS, making it easier for us to capture data. Remember, what we are doing right now won't work on HTTPS protected sites. But don't worry, we will cover how to bypass HTTPS later in this course. Let's go back to the Kali machine, where BetterCap is running. As you can see, every request made by the Windows machine has been captured, including requests to the Google and the site oneweb.com. We can even see files loaded from the site, like images or style sheets. As you can see, the visited file, as you can see, the visited site where our target machine was visited. Next, let's test capturing some login credentials. I will go back to worldweb.com and open the link and enter username. I will try logging in with the username admin, and password 123456789 and 0. Once login, I will be go back to the my Kali machine. If we scroll through the captured data, you can see the exact login request sent to the site, including the username and password in plain text. As you can see, anything the target device sends or receives can be captured by our Kali machine using BetterCap, whether it's a computer or a phone, and whether it's connected via Wi-Fi or wired network. We explored how to use BetterCap to discover all the devices on the network, launch an ARP spoofing attack, and capture data including usernames, passwords, and much more. But each time we did this, we had to manually run several commands. For example, we had to start by enabling the net.probe module, configure the ARP spoofing settings, and then run the sniffing module, but it requires multiple steps each time. If you are like me and you don't want to type all those commands every time, there are much simpler solution is Caplet. So what exactly is Caplet? It's just a text file that contains all the commands we want to run in BetterCap. Instead of entering them one by one, we can create a caplet to do it all automatically. Let me show you how it works. We are going to start by opening an text editor. The first command we always use is netprobe.on. So I copy that and paste here. This command enables the network recognition module to discover all the devices on the network. We set up the ARP spoofing module. We do this by setting it to full duplex mode with the command set ARP spoof full duplex true. I will copy that and paste here. Next, we set up the ARP spoofing module. After that, we need to specify the target IP, one you are targeting. Here, make sure you replace the IP with the one you are targeting. After that, we need to specify the target IP, which is that ARP spoof targets 192.168.73.174. Here, make sure you replace the IP with the one you are targeting. So I'll copy that and paste here. Finally, we add the commands ARP spoof on to activate the ARP spoofing net snip on to start the sniffer module. Once you have all the commands ready, save the file with the .cap. Once you have all the commands ready, save the file with the .cap extension. Now I save the file. In my case, I will call it spoofing.cap file. Select the root, save it. Now, instead of manually entering each command, we can run BetterCap with the caplet file. To do this, we just use the caplet option followed by the name of the file. For example, now I clear the screen and exit and write command BetterCap iface pth0 caplet and our file name spoofing.cap. This will automatically run all the commands in the caplet file. Let me show you how it's work. Now I can check the services. You can see the ARP spoof, NetPro, NetRecon, NetSnip are active. I'll check the ARP table on my target machine before running the caplet. This will automatically run all the commands in the caplet file. Let me show you how it works. I'll check the ARP table on my target machine before running the caplet. I check the ARP. As you can see, the MAC address for the router is set to its real value. Now when I run the caplet, now I run the caplet and run ARPA into target machine, the ARP table updates and you can see that the MAC address of the router has been changed to that of my Kali machine, meaning we successfully performed the ARP spoofing attack. Just to confirm it's working, let's go back to our test website and I will log in again with a username and password. And log in. Now let's move to our Kali machine. And as you can see, we are able to intercept the login detail right here on your terminal, and we get the username and the password. So what did we just do? We used a caplet to automate the entire process of ARP spoofing and data sniffing. This is super handy if you are going to perform these attacks frequently. Instead of typing everything out each time, just run the caplet and let BetterCap handle the rest. Then we are going to dive into how we can bypass the security of HTTPS and downgrade it to HTTP, enabling us to capture sensitive information like login credentials and passwords. Remember, this is for educational purpose only. So far we have focused on how man-in-the-middle attack work on HTTP websites. The reason why this is possible because HTTP send data in plain text, which means anyone intercepting it can easily read and even modify the content. However, most websites now use HTTPS, which secure data by encrypting it, making it unreadable to anyone trying to intercept it. HTTPS use SSL or TSL protocol to do this, making it extremely difficult for attackers to break through. Since breaking HTTPS encryption is complicated, the easiest way around it by downcoding the connection from HTTPS to HTTP. This allows us, as the man in the middle, to intercept and read the data in the plain text. BetterCap makes this process much easier for us. There is a caplet in BetterCap specially designed for this, but it does not replace all HTTPS links properly. That's why I have customized this caplet to work as expected, and I have included it for you in the resource. Now let's set it up. First, download the HSTSS hijack.zip file from the resource and extract it. Once extracted, we need to move the caplet file to BetterCap's default location, where it stores caplet. Now I'll copy the folder, copy, and open path by pressing Ctrl L and navigate to a caplet file to BetterCap's default location. So type user local share BetterCap applets. As you can see, HSTSS hijack folder. It is a default folder. Now I will delete the folder and delete the existing buggy caplet and replace it to our customized one. So I will delete it and paste here our customized caplet. And before we start using the caplet, we also need to modify our sniffer caplet from the previous lesson. This caplet run the ARP spoofing and sniffing commands, open it in a lib page, and add the following line that net.sniff.local true and save it. This ensures BetterCap will capture all the data even if it thinks the traffic is local. If we don't do this, BetterCap might think the intercepted data belongs to our computer and ignore it. Once we have made this modification, you are ready to go. In the next video, I will walk you through how to use this caplet to downgrade HTTPS connection to HTTP. And we will see how we can sniff sensitive data like usernames, passwords, and URLs. Now that we have covered the theory behind bypassing HTTPS and have our caplet set up in the correct path, it's time to get hands-on. Today we will be using BetterCap to downgrade HTTPS to HTTP and demonstrate how we can capture sensitive information like password from websites that default to HTTPS. So let's jump right into the terminal. I will be running BetterCap just as we have done before. We will use the IFS argument to specify our network interface and then use the caplet argument to load the spoof caplet. This is the same caplet we built earlier and it will execute the ARP spoofing and sniffer command automatically. As you can see, everything is running properly. If I type help, we will see that all the relevant modules like ARP spoof, sniffer, recon, and probe are active. This is exactly what we want. Now, the next step is to run HSTS bypass caplet we just placed into the BetterCap directory. If you want to see all the available caplets in BetterCap, you can simply type caplets.show. Here, as you can see, here is our caplet. This gives you a list of all caplets along with their paths. We are focusing on HSTS hijack caplet. It's located here in the bettercap directory. To run any of these caplets, all you have to do is start typing its name and you can use tab for auto completion. Now that we have run the caplet without any errors, it's time to test it out. Let's head over to our target machine and try to browse some HTTPS website. Here is my target machine. Before starting, it's always good idea to clear your browsing data to avoid loading cached version of the website. Now open the browser and I will quickly do that using Control, Shift and Delete and select all items to clear everything. Let's visit demo fire.net, which typically use HTTPS. If you look at the top of the browser, you will notice it's loading over HTTP instead of HTTPS. Exactly what we want. Let's enter some login details and I will use save at the rate s3 cloud hub.in and 123456789 as the password. Although we get an error on the page. Let's check our Kali machine to see if we capture any data. As expected, we have intercepted the login request and here is the username and passwords. And here is the username and password. However, this method won't work on websites like Facebook or Twitter that use HSTS. That's because Facebook uses HSTS, which is harder to bypass. In the next video, we will dive deeper into what HSTS is and why it's more challenging, and how we can partially bypass it to still capture username and password from websites that use it. Let me explain why that happens and how we can bypass it. So, what is HSTS? Well, modern browsers like Chrome and Firefox come with a built-in list of websites that should always be loaded over HTTPS. Even if we try to send back an HTTP version of the site, the browser ignores it. This list includes popular websites like Facebook, Twitter, and others. And once we become the man in the middle, there is nothing we can do because the browser locally checked this list. The browser does not even send a request over HTTP. It directly uses HTTPS and only accepts HTTPS response for these websites. So, how do we can bypass this? The only practical solution is to trick the browser into thinking it's loading a different website. We do this by replacing HSTS link with similar looking but slightly different domains. For example, instead of facebook.com, we can replace it with facebook.com. I know this seems obvious when you hear it, but visually the letters R and N together look like M in the browser's URL bar. Another example is replacing twitter.com with twitter.com using just one T instead of two. This might sound confusing right now, but don't worry, I will show you exactly how this works in practice. I have my Kali machine ready and we will be using an HSTS hijacking caplet with bettercap. In the previous lecture, I show you how to downgrade and place this caplet in the right directory. Here how it's works. The caplet is stored in user share bettercap caplets HSTS hijack and is named HSTS hijack.cap. Right click and open it in a text editor. You will see pre-configured targets and replacements. Target are the website using HSTS like twitter.com and .twitter.com. The wildcard means it's target any subdomain of Twitter. Replacements specify the spoofed domains. For example, twitter.com becomes twitter.com You can modify this replacement if you want. For instance, you could use twitter.com with a single T instead of con. It's flexible. Now, it's crucial to ensure that the DNS spoof domains are set exactly the same as the replacements. I literally copy and paste them to avoid mistakes. Once everything is configured, we are ready to run the attack. Now I close it and open terminal. Once everything is configured, we are ready to run the attack. The process is almost identical to what we did in the previous lecture with ARP spoofing and running BetterCap. Here is a step-by-step breakdown. Run BetterCap with the command we used last time. And load the HSTS hijack caplet by typing HS and pressing tab to autocomplete. Once it's running, switch to the target machine. Let's use a Linux machine running the latest version of browser. Now, on the target machine, I am going to open browser. And first of all, we clear the browsing data by pressing Ctrl+Shift+Delete and clear all. Now, I enter www.linkedin.com. As you can see, the website loads in HTTP and I click the signing button and try to sign in s3cloud@gmail.com and password 12345678990. Now I press the signing button. Let's move to our Kali machine and check what we can capture it. As you can see, we successfully captured the username and password. This method allows us to bypass HSTS, but it's important to note that it only works under specific conditions. The user has to first go to the website that does not use HSTS before visiting the target website. So, while this is a clever trick, it's not a full solution for bypassing HTTPS protections, but it's still very effective in the right circumstances. In the next lecture, we will dive deeper into other techniques like JavaScript injection to extend this attack. Thanks for watching and I will see you in the next lecture.